Today we're going to see what happens if you put rocks in a vacuum chamber and try and explain the result that we get. Over the years, we have had dozens, if not hundreds of people asking to see what would happen if we put a rock in a vacuum chamber. I'm pretty sure I already know the answer, but because so many of you have asked, we're going to try it and then we're going to discuss why we're seeing what we're seeing. The idea here is about as simple as it gets. We'll take a few different types of rock, put them into our vacuum chamber, and suck out all the air. I've got a few different types of rock here. This one I just pulled out of a planter box. It's a pretty standard looking rock. Feels heavy, it's hard, I would just call that a rock. This second rock is a volcanic type of rock that's called scoria. It's formed when lava comes up out of the ground and hitting lower pressure forms lots of bubbles and then cools off like that. It's not quite as light or air-filled as pumice, but it is similar. These two rocks are varieties of what at least claim to be pumice. They're both commercially available. This black one is sold at fabric stores and is designed for restoring the proper texture on sweaters. It's extremely lightweight and basically feels just like a sponge, except it's made of rock. This second one is a cleaning stone. I just got this at a department store. It cost like $1.50. Again, this claims to be natural stone that's just been cut into this shape. I'm not sure if it's supposed to be actual pumice or just something a lot like pumice. Pumice is another type of volcanic rock that forms about the same way. As the magma comes up out of the ground, it's no longer pressurized and all of the dissolved gases in it form bubbles and it then solidifies in that state. Pumice is supposed to be a rock that's so light and full of air that it can actually float on water. And we'll probably do a little bit of that in a minute after we've done our vacuum tests. I don't want to vacuum them while they're wet, so we're just gonna do our vacuum test first, and if they survive, we'll try the water thing. We're now going to take each of these rocks and give them a chance to experience being in a vacuum chamber. We're gonna start with our densest rock. Just set that down in there and see what happens as we pull all the air out. All right, that didn't do anything. In fact, it did so little that I'm gonna add a visual aid just to show that things are getting vacuumed. This is a Ziploc bag, and it's just sealed off. We're just gonna add just a tiny bit of air into it. So now let's see if the bag does anything while it's in the chamber with the rock. This is just so we can see if we're really getting low pressure. Bag is already moving. The bag can barely be held in place by our vacuum chamber. All right, so the bag's expanded. You can see the difference in the vacuum. You can see what happened. Oh, wow. And now it's collapsing. The bag expanded a ton as we sucked all the air out of our jar. The rock did not move at all. Rock 1, vacuum chamber 0. Let's move on to our scoria rock. This rock has a lot more air in it than the last one, so maybe it will be different. I think that's as low pressure as we're gonna get. And once again, a whole lot of nothing happening to this rock here. That was air rushing from the valve, pushing on the rock, not the change in pressure. All right, let's move on to our really lightweight rocks. I think this one is next up in density. Nothing with that stone. We've got one more left to try. That's about as much vacuum as we're gonna pull. And really no change at all. I just want to do a little test. You can't really feel these different rocks, but we've got a scale here. We've got grams, and in grams, this rock is 147, And this rock, which I would say is approximately double the volume, 22. So this rock weighs more than 6 times as much as this pumice brick here, and this pumice brick is probably twice the volume, which means this is 12 or 13 times less dense than this rock. This one has so much air in it. We are going to do a quick demonstration to see if these two rocks float on water. Seriously, this one is like about the density of styrofoam, I think. Floats extremely well. Now that I've put this in the water, we're going to throw it back in the vacuum chamber and just see if it pulls any water out. Not really much there either. So the water that got on this wasn't really pulled into the stone at all. It was mostly just on the holes in the surface of the stone. But why is it that we can put a Ziploc bag in with almost no air and it balloons up to fill this whole container, but the stones that have so many little bubbles don't really seem to do anything? It has to do with how a vacuum chamber works. Normal air, the air that's around us, if we are at sea level, that's approximately 14.7 psi, which stands for pounds per square inch. That means that every square inch on your skin, your clothes, everything around you has about 15 pounds of pressure on it. That's like the size of a large bowling ball pressing down on it. It doesn't feel like that because that's always there. That's what we've grown with, and down to our very cells, that's what's normal to us. When we start pulling the air out of the vacuum chamber, it's no longer pressing on things. So inside this Ziploc bag, if we just open this bag, put a little bit of air into it, and then put that into the vacuum chamber, when we turn the vacuum chamber on, there's no longer 15 psi squishing down on this bag, but there is still air inside. And that air went into the bag at 15 psi, which means if we pull a perfect vacuum, all of that air would begin to press out with that same pressure. That would be 15 psi of air inside a Ziploc bag, and a Ziploc bag can't really take that much pressure. It's got thin plastic walls. Squashed down flat again, back to the almost entirely empty that it is. But the thing is, it's not perfectly empty. There is a little bit of air in this bag, and we can sort of maybe squish it all into one spot or something like that. And we could see that that tiny, tiny amount of air is what's expanding on the inside when the vacuum chamber is turned on. So there you go. That's how much air there was in this bag. And that expanded to completely fill our little vacuum chamber. So if the bag has a little bit of air in it and the stones have a little bit of air in it, why is it the bag inflates but the stones don't really change? They don't inflate, they don't crack, they don't even chip. There's not dust flying off of them. All through the inside of this rock are tiny little air bubbles. And when you pull the air out from around them, they do start exerting pressure. And as I said, 15 psi is a good amount of pressure. Each one of these tiny little bubbles is only 1 or 2 millimeters in diameter. And although 15 pounds per square inch is quite a lot, when you divide it up, it stops being so big. And I know I'm crossing measurement systems here, but 1 square inch has approximately 645 square millimeters in it. And when you divide the 15 psi of the atmosphere by 645, you end up with 0.02 pounds of pressure. 0.02 pounds of pressure isn't enough to break through the walls of this stone. It is a soft stone. I think I can even just break it off and crumble it in my fingers, but it's still not soft enough that that tiny, tiny amount of air can break through the walls of it. So can you break rocks apart by using a vacuum? No, you cannot break rocks apart by using a vacuum, at least none of the rocks that I have available to me. There may be some kinds of pumice that are so light and so weak and so full of air that you can pull them apart, and that seems like it would be pretty fun to do, but I've never used one of those rocks. I've never seen one as far as I know, and I don't think I'm going to be able to get my hands on one. But it's interesting to learn about why some things react and some things don't. And that's also sort of a thought experiment when you're wondering what would happen to something if you put it into a vacuum chamber. Is the amount of air that's inside it enough that it's going to overcome the pressure of whatever's holding that air in place? So it is good to try things out, although knowing how the vacuum chamber works and what makes the difference between something that does or does not expand can give you at least a start of an idea when you're wondering what's going to happen. Guys, that's not all. We've always got more for you to see. That box up at the top will take you directly to our last video, and you should go check that out. The other box will show you what YouTube thinks you should be watching next. And if you aren't a subscriber yet, just hit this bomb to get in the club, and that way you'll never miss out on the fun. Don't forget to ring that bell, and we will see you in the next one. Talk to you then.